Hello, everyone. Thanks for inviting me to this talk. So I'm Dr. Nong Yi. I'm from Singapore, Nanyang Technology University, and I'm talking about the smart windows for energy saving. So there will be two projects here. The first one is a liquid smart window, which can be used to regulate light and also at the same time provide the high thermal energy storage capability together with the soundproof abilities. And the second project will be the video cooling regulated passive smart windows. But why I spent last decade to deal with this smart window? From this chart, you can see 40% of total energy has been consumed in buildings and in buildings. Okay, among this 40%, 50% coming from the heating, cooling, and energy consumptions. So actually, in all the buildings, the least energy efficient part is windows. Okay, so there's a data saying that in the United States alone, in 2015, 4% of the primary energy has been consumed through the windows. Okay, so there's some more details. For example, like in hot seasons, more than 70% of the window-directed solar energy will be converted into heat and into high cooling demand, while in winter, windows are responsible for 30% of the energy loss. And the global market for the smart window will be over 8 billion in 2023. And personally, I think this will be much bigger, actually. And let me move to the first one, okay, the liquid smart window. Okay, so why we develop this liquid smart window? Okay, so you can see what we do is we just put something which is smart, and this one we call liquid phase change materials. Okay, so this one can change phase, but it's from liquid to liquid phase change, and which is going to give a smart regulation of sunlight transmittance from 70 in winter and to 10% in summer. And also at the same time, 5 times higher thermal storage capability compared with glass. At the same time, we can also put thermal insulating properties and also very good soundproof performance. So you can see the liquid phase, which is liquid and pour into 2 glass panel, and these are the window, and the seal with the glues here. So you can see, so these are the windows. So then why we do this one? So you can see, so this is what we have set up in Singapore outside of my lab. So if the temperature is 29, so for example, if anything is below 29, so it's going to be very clear and transparent, which means the light can pass through, can provide enough heat. So you can imagine this in China or in other European countries, if it's in winter, if you need sunlight and winter, because the temperature is low, right? Because this phase change materials, which means if temperature is less than some transition temperature, in my case, which is 30 degrees. Okay, so if it's less than 30 degrees, so in this case, so it will turn transparent. So that's for winter scenarios. So you can see the light can pass through. But if the outside temperature goes up above 30 degrees, so it will change either opaque or translucent. This one translucent or opaque. Okay, so you can imagine if in summertime, especially in Singapore, when like in the middays, it's going to be very hot. So this glass is going to turn automatically into opaque and also all translucent depending on the customer requirement. So we can tune this, what we call opacity and the translucency. Okay, so and also the good thing is because it's a liquid, so you can just simply pour in. So it's very easy to make this very uniform glass. So you can see I'm standing behind. So this glass panel is 1 by 1 meters. So it is very easy to scale up because as a researcher, because I'm an academic and faculty professor, so not most of the time we can only produce very, very small samples, then we pass the technology to industry. But this technology, so because it's a liquid, so it can flow everywhere. So there's no limitation of the size and the shape of the glass. So, and also it will be very uniform because if some of you know the Louis glass, they coat some silvers, very thin layer, a few nanometers, thin layers of silver on top of glass. So they have very high requirement on the coating qualities and very large scales. So actually it's a very high standard of processing there. But this technology is very simple. So you just mix a liquid, then pour in, and it can go anywhere. So it will be very uniform and can very easily get upscaled. Okay, and also there's another advantage which has never been really discussed before in the window technologies. This heat capacity, because you know the double glazed glass, right? Double glazed glass, they put air in between. What about if we put a little bit like water-like materials? So, for example, why we put water? Okay, because water itself intrinsically have one of the highest specific heat capacity and the thermal energy storage capabilities. Okay, so this is just wonderful. So water itself, it is already a very high large thermal energy storage capability and this heat capacity. So you can see compare with the normal construction materials which are here and some of the commercial phase change materials which is used to store the heat. So it would always be here. Okay, paraffin, like a fatty acid. So it's naturally is higher. So what we have here is we have mixed some liquid and more than 98% are water. Okay, so which means naturally we're going to use this water, the advantage of waters. Okay, so that's what we'll put here, the water and the fatty acid. Okay, so that's why I can say if we just simply put water, 1 centimeter water. So what we do is we have done a fish tank experiment. So we'll put a fish tank. Yeah, just outside Singapore, because Singapore is hot all the time. It's very sunshine all day. So we just put a fish tank and we either wrap this glass tank with with just a normal glass. Normal glass is here, so you can see if just a normal glass. So at about 12 o'clock, so the temperature can even up to 85 degrees. So it's very, very hot because it's a glass box, okay, like a fish tank, okay. But if we put 1 millimeter of this liquid, 1 millimeter of our liquid, so you can see we can drop the temperature immediately from 85 to about 65, right? But if we just put the water, can also reduce the temperature a little bit, so about the 60. But if we put 1 centimeter of our smart water, it's not water anymore, it's smart water. This water can change from transparent to translucent, okay, or opaque, okay. It is smart, it can respond to temperature automatically. So this time you can see because the temperature is high enough, so the glass has changed into the opaque, so you can block all the heat. So you continue to just drop down the temperature to about 55. So that's the first thing. First of all, because we know that our smart liquid can just change into its translucency from transparent to opaque. So it can block most of the solar transmission, so which is block the heating source of the sunlight into the room, so which is going to cool down the room from 85 to about 55. So it's about 30 degrees. Of course, we are just talking about the fish tank of this size. Okay, so about 30 degrees. And also at the same time, we want to mention another thing, which is this peak shifting. So if you are in the building industry, you know the phase change material, right? Because they can store the heat, so they can release slowly later. So that's the essence of the phase change materials. So that's the beautiful part of the water here. So because of the very large water content in this smart liquid, and also at the same time, and because also it's thicker, right? Because you have to be thick enough, 1 centimeter, 1 centimeter of the liquid put inside. So you can see we can also shift the temperature peak from about 85, so for about 12 o'clock to about 2 p.m. Okay, so this is peak shifting, which is quite meaningful for buildings, because you can imagine if Singapore, everyone uses this normal glass, which means at 12 o'clock, so everywhere is supposed to be it had highest temperature. So which means at this time, the electricity demand is highest because everywhere is the highest temperature. But we can shift the peak to about 2 p.m., 4 p.m., or 3 p.m., or 5 p.m. So this will even out the demand of the electricity. So this is very important for the electricity grid. And we use a simulation to calculate that we compare with normal glass, Louis glass, double-based glass, and our product. So we are going to see a very good energy saving performance in Singapore, about 35% of the HVAC energy reduction from double-based glass, and 30% better than the Louis glass. Yeah, so that is from the calculations if we're using a commercial building to calculate. And also there's another advantage, which is very interesting because it can offer this very good soundproof performance. It's because now you can imagine we just trap a liquid in between, right? So compare with, because the normal soundproof glass is just a double-based glass, just put air in between. Okay, but now we put a liquid in between, so we're going to get a 15% higher rated sound reduction compared with a double-based glass. Okay, so compare with commercial glass, we're 15% better. And if you compare with normal glass, we're 25% better. So this is another added advantages. Okay, and also we have done this durability test. So the 14 days after 16 test, so the degradation of the light transmittance is less than 10%. So we use a calculation suggesting that such window can last for 18 years in working condition without significant performance degradations. Okay, and it's very simple, as I said. So the solution is just simply use a mixing, then we just pour in. So you can see this student just use a beaker to pour in the liquid in between the glass panels. So this is another advantage, very simple fabrication process. Okay, and so if we compare with other products like electrochromic, Louis glass, and double-based glass, like all these are commercially available glasses there. So first of all, there's no automatic response because my material is a smart material, which means it can respond to temperature automatically. For example, in this case, it's 30 degrees. Above 30 degrees is going to automatically change into opaque, and below 30%, it is just transparent. Okay, but for others, they don't have such functionalities. And also, there's no energy storage as a phase change materials in other categories. And the lifetime is long, and the structure is very simple. Right? You can already see just a double base and just put in. But electrochromic, this is another smart window, so it's very complicated because you need an electrode to conduct. Okay, and the production cost is about 100 RMB per square meters. Okay, compared with electrochromic, so which is 1,000. And also, we just mentioned that liquid trapped glass has very good uniformity and is very suitable for the compact shape and curved glass applications. Okay, and this technology has been publicized more than 50 countries and 80 medias, including Reuters, AFP, CNA, and Zaobao, and many more. Okay, so it is one of the most publicized technology in NTU. And the take-home point for this technology is excellent energy-saving performance, peak load shifting, good uniformity, good scalability, and soundproof. And also, we have shown our strong team and excellent track record. So now let's move to the second project, which is video cooling regulated passive windows. So first of all, let me introduce one concept here. What is video cooling? So video cooling is what? Okay, so you can imagine if you go outside, right? So as a person, you go outside. So at one time, you receive the heat from the sunlight, right? The sun just warm you up. At the same time, you radiate your heat back to the outer space because the outer space is absolute 0 degree roughly there. Okay, so which is minus 270 degrees. So which means what? You are actually receiving heat from sunlight, and also you are just radiate your heat back to the outer space. So you can imagine. So you have these two sources. One is heat source, the other one is cold source. So the best scenario for summer is you receive as little sunlight as possible, but radiate heat back as much as possible to the outer space, right? So the winter, which is opposite. So winter, you need to receive as much sun heat, solar heating as you can, but at the same time, you're trying to suppress this really cooling to the outer space. Okay, so that's the part people never studied before. So we propose an ideal window here. So you can see the ideal window. So you can see, so of course, window you still need to keep certain visibility, right? Otherwise, people will say, hey, why use window? Okay, but you brought the near infrared, but at the same time, you have as much video cooling as possible. Okay, so that's what you can see here. So winter, we need make the visible to come in, but block the NIR because NIR is going to heat you up, okay, heat the room up. Okay, but at the same time, we have very large relative cooling and relative heat back to the outer space. So at the same time, you can see it's winter, so we want as much of the light, the solar heating to go in, visible past near infrared. At the same time, we're just trying to suppress the relative cooling, which means we don't want really our heat back to the outer space. Okay, so this is a completely new concept. So that's why we published in the top journal in Science. So this is maybe the first science paper about Windows. Okay, never published anything about Windows before in Science. Okay, because Science is the top journal in the research community. Okay, and also the technology is very simple. So we just again use a solution process, a simple solution process to fabricate these structures. And we can realize this approach to this in summer. We can just reduce the solar heating, but enhance relative cooling. But in winter, we can reduce the relative cooling, but at the same time enhance the solar heating. Okay, so actually window is the most difficult part and the most complicated part. Okay, so it's very, very difficult. So this is our sample. So if without our structure, so you can see, we can just we can still modulate in the solar part, which means we can still trying to reduce heat in summer and give more heating in winter. But we cannot really do much with the relative cooling, which means the cooling part with the outer space is not possible. Once add up our structures here, so you can see we can just modulate the heat, which is this region, and also the relative cooling at the same time. So this one is selected by the German Department of Technology as the 10th breakthrough in the world of 2012 or 2022. Okay, so this is we are very proud of this one. And also we have done the simulations because this one, as I said, is more, the first technology, the liquid smart one is more for the tropical weather, so will be a little bit better. But for this one, because we can modulate everything at the same time, so that's why we can use all over the world, okay, across the globe. So we have calculated across the whole region from Singapore to Moscow. So the energy saving can be up to more than 10% compared with some commercial UV glass. So take-home point for this breakthrough of this technology is a modulate both heating, which is solar transmission, near infrared, which is from 7.78 to 2.5 micron, and relative cooling, which is a long wavelength 2.5 to 25 microns, favorably in 4 season countries. And we can, and also the good thing, this one is again a passive control, which means we don't really need any external circuit to control it. So it's going to respond to temperature automatically. And this is across the 7 climate zones, energy saving both in summer and winter, up to 15%, depending on which region we're talking about. So this is a technology heat up in summer and cool down in winter. And also, we're the top scientists in the world in terms of Windows. These are some publicities. So these are some like publicities in Chinese academia media platform in China. And this is our top journal publicities, including Science and Jewel and Latest Memo. And these are the top journals cover report. Okay, and myself is I'm graduating from Cambridge, and I have a very unique career is because I started with transfer technology to industry, including I have successfully developed a solution process to Seagate technology. Seagate is the leading hard disk company in the world. So I'm a little bit special. I have experience with VR. I have experience with transferring technology to industry. At the same time, I'm a good scientist anyway. My recent work is related with functional coatings. And I have published more than, actually more than this already, 90% invited reviews. And also I have won the Green Awards and this 2016 Tech Connection Innovation Awards, and also the latest 2022 the Falling Wall Award. Thank you very much. Yeah, and also myself is highly recognized in the academia community. So I'm serving as a pioneer in MIT, this buildings colloquium. Okay, so I'm the only person talking about Windows, and I'm giving lectures to China about this energy consumption, zero energy consumptions. Okay, so I'm the only person talking about Windows, and also my research has been highlighted in Nature. Okay, so that is all for my presentation. Thank you.